Greetings, everyone. Through here, welcome to the Demo Hub. Welcome to the show. We are excited for another episode today with a tool in the modern data space that's fascinating. We're going to jump in today, talk with the founder, and see a demo of that tool. In today's session, we're going to be looking at Dagshub. For today, we have as guest Dean Pleben. Dean is the co-founder and the CEO of Dagshub, and we are very excited to have Dean today on the show. Dean, welcome to the show.
Thanks for having me. It's a pleasure to be on the show. Yeah.
That's awesome, Dean. Where are you calling from today?
So I am in a small city called Givatayim, which is close to Tel Aviv in Israel.
That's awesome. Thanks for joining from Tel Aviv. So can you talk about Dagshub for the audience who don't know what Dagshub is? Go as much into the details of the history and the story of Dagshub as you can.
Sure, fair enough. So the way we usually present Dagshub when we have to say it in just one sentence is that Dagshub is like GitHub for machine learning. The idea is that if GitHub is the place where software teams manage their code, Dagshub is the place where data science and machine learning teams manage not only their code, but also their data, models, experiments, and pipelines so that their entire project exists in one place. And the sort of core values that we're trying to bring to the table is having a single source of truth, which we think is really important when you want to build for production, for the long term, etc. And so you want to be able to have multiple people working on the same thing, understanding what each other is working on, and then being able to review the work being done. And that sort of naturally leads to solving for collaboration. So if you're really working on a project that scales and goes to production, it's usually not going to be just one person. And so we spend a lot of time and effort on what does it mean to work as a team on a data science project, i.e. visualizing the data, but also comparing different versions and then being able to review and comment on these different versions. And the way we do this is basically, again, taking inspiration from tools like GitHub, is all of the core technologies are popular open source tools. And we think that that's also really important for the way data scientists work today. So what that means is obviously we use Git under the hood to manage the code files, but we also build on top of DVC, which is a popular open source tool for managing your data and model versions. We build on top of MLflow, which is a very popular open source tool for managing experiments. And we build on top of Label Studio, which is a very popular tool for labeling and annotating your data. And so that provides us with great core technologies and standard formats so that we're not reinventing the wheel. And it lets us spend more time on thinking about what it means to work with all of these tools together in a collaborative way. And that's what we actually do.
That's pretty awesome. And I can't wait to jump in and see the demo. But essentially what you're saying is Dagshub is to DVC as GitHub is to Git. Is that a good analogy to think about it?
Yeah. So I think that the good mental model for this is in software development, code is the source code, but in machine learning, data is also part of the source code. So if you and I are working on the same code base, but we have two different data sets, our results are going to be very different. And so the ability to treat your data in the same way that you treat your code is very important to be able to manage these projects.
Mhm.
Now, factually, there are additional differences between the data science work to the software engineering work. And the other major one, aside from data being sort of part of the source code, is the experimentation aspects of it, which means that in software, our internal joke is if you want to build something, right, in the world of classic software development, it's not a matter of if it's possible, assuming you're not trying to break the laws of physics. It's more a matter of how much time you're going to invest in building it, right?
Mhm.
In machine learning, that's not necessarily the case. Like you might want to do something, but you'll experiment and none of your experiments will be successful. And that's part of the way things work. So you need to be able to account for the experimental nature of data science compared to software development. And that's also why I would say like Dagshub is to DVC plus MLflow plus Git.
That's awesome. And I think you've gone ahead to answer the question. This question is really for the audience who might be sitting and saying, I'm familiar with GitHub already because there are folks, 90 million plus developers on GitHub who use GitHub for managing their source code, as you said. What stops them from bringing their data sets into GitHub, version controlling that, and just managing that along with your code? I know what the answer is, but I want to get your thoughts on that.
Yeah, sure. So I guess the easy answer here is what I said a moment ago, which is it's not just their data, right? Like they
Mm-hmm.
need other things to be there for the picture to be complete. And again, I'm a great believer in technical people in general, developers, data scientists. Like people can build whatever they want, but it's more a matter of like what's the most convenient way to do things
Mm-hmm.
and how can you spend time on what is most important for you. And I think that the current paradigm with GitHub is that these other components have to exist. Like you can't do a machine learning project without having your data and your experiments and your pipelines and annotations
Mm-hmm.
somewhere. But just what happens today is that they're somewhere else. And so there's a lot of work on synchronizing all of these tools, which leads to things falling between the cracks. It's harder to onboard new people. It's hard to hand off work and things
Mm-hmm.
like that. And so that's sort of the high level answer. The more technical answer is that, yeah, in theory, you have Git LFS, which is sort of to a certain extent, a competitor to DVC, which lets you manage large files based on Git. And
Mm-hmm.
GitHub does support that. But you can really see in how they built the support for this that it's not oriented towards data science work. Like the Git LFS files that are being tracked are an afterthought. They're not as important as the code files that are tracked by Git. But in the case of data science, I would argue that the data is more important. It's at least as, if not more important than the code. And so the idea is that on Dagshub, you get the features and the feeling that the data
Mm-hmm.
is put on an equal level. And that matters a lot, especially for visualization, for diffing when you're dealing with, a world of code, maybe changing 15 code files and having 10,000 code lines added. That's a huge pull request. But in data science, changing thousands of images is just another day of work, right? Like that's
Mm-hmm.
what you do all the time. And so being able to manage that in a way that the reviewer can actually understand what's going on, that's very hard. And that's part of the magic that we do.
Oh wow, that's pretty fascinating. Thanks for going to that. And let's jump into the demo. A big part of this is for the audience to get to see and get a feel of the product. So once you're ready, we can jump into the demo of Dagshub.
Sure, let's do this. So let me try to share my screen. Cool. So everything I'm showing here today is the real live version of Dagshub. One of the things that we haven't mentioned earlier is that Dagshub is totally free to sign up and use. You can open public projects and private projects. And the idea is that we want to make it easy to start using it and get value out of the platform. We basically, to make this clear out of the box, the pricing model is built on the idea that when you're working in a team that's growing over time, then you're going to need to pay for the team access controls and everything. But the core functionality is available to basically everyone, both in public and private projects, so you can just start using it. Now, what I'm showing you here is my dashboard, but I want to dive first into the Explore page, which is where some of the unique magic of Dagshub happens. So what you're seeing here are projects that were created by the Dagshub community. We have over 15,000 data scientists on the platform, and they're creating projects. Some of them are closed source, but a lot of them are open source. And you can see that they're all over the place with respect to the type of data that they're using, the type of machine learning that they're doing, and the type of integrations that they rely on. But you can see even here that there's a computer vision project or two, and an audio project, and maybe some math related machine learning project. So there's a lot of different things going on, and you can look into things that other people are working on, understand whether or not you're interested, and then actually make a contribution and be a part of this. And part of the added value that we're trying to bring to the table is the ability to contribute as a data scientist. So it's not just bug fixes, or I'll show you in a moment. It can also be contributing data or finding problems in your data and then reporting them to remove data or relabel data. That's all part of the game. And that's part of what it would mean to have community data science projects. So I'm going to go to computer vision and hopefully find one of the projects that I work on in my spare time. No, so let me search. I'm going to show you a project that is called SAFTA depth. It's basically a monocular depth estimation project. So what I'm trying to do here is take a 2D image and estimate the depth of the different components. So this is Sunny, my dog. She's now outside this room sleeping on the couch. The model is trying to predict how deep she is within the image objects. And the idea is that this is used for creating 3D images out of 2D photos, but also for autonomous vehicles. So this is like a real data science and machine learning problem that is being solved in industry right now. I'll get back to this in a moment. But when you're looking at the top of this page, if you've ever looked at a GitHub project, this should look pretty familiar. And part of the idea that we're trying to go after is that you don't need to relearn where the different components exist and everything seems kind of familiar, but there are a lot of differences, and each difference relates to something a data scientist would care about. Two things that usually come up is people see like these tabs, right? So you don't only see code files. In this case, I'm seeing all of them, but you don't only see the Git track files. You also see your data files. You see models. You see notebooks that you might be using in your project. And then, as I said, we support both DVC, so you can see your DVC track data and your Git track data. But everything sort of exists in one place and is easy to find. The other thing that's interesting is in GitHub, you have a button that says code, but in Dagshub, it says remote because we're not just managing your code. So you have a Git remote that comes with every project, but you also have a DVC remote that you can use or connect your own S3 or Google Cloud Storage or whatever, any storage bucket that you're using, and an MLflow server that you can just start using to track your model, your experiments without doing any extra work. So what you get in return for all of these integrations is basically, if you look at these files, right, it looks kind of normal. But if I go into my source folder, I'm going to start seeing folders and files that are marked with the DVC badge. If I look at this project on GitHub, for example, or any Git server, I wouldn't see these files because they're not managed by Git. And part of the magic of Dagshub is that we're piecing together the information from these different components, and we're presenting it as if it was one holistic project in one place. And so if you're imagining this on your local system, when you open your process data folder, you'd actually expect to see the data, right? And that's exactly what we're giving you with Dagshub. So I can open my process folder, and open my train folder, and go into one of these folders and open a file, and you're actually going to see the training data that I'm using for my model. And this is really cool. Again, this looks like a Git track file, but it actually is a DVC track file. And the idea is that I can move between the different data points that I have. I can see them very easily and understand what's going on. And this is really, really, really large scale, right? Like in this project, I'm using 3,000 images and 3 gigabytes of data in this data set. But we also have users with millions of images and terabytes of data, and it works as fast for them. So there's a lot of work behind the scenes on making this very easily and quickly accessible. But we don't stop with only showing the data. We also think about what it means to compare different data versions. So in this project, I had a problem where I was saving the values of pixels opposite of what they should be. So things that were closer were supposed to be brighter, but I was saving them as darker. And that obviously ruined performance, and that's not what I want. And so you can see that after I fixed my bug, I can actually compare the different versions of my data. And both of these files are not tracked by Git, they're tracked by DVC, but I get the diffing experience as if they were just 2 Git track files. And this applies not only to images or text, but also to things like my tables. And so here you can see like the columns that have changed and how the values within them have changed. But even, and I'll move to a different version, a different comparison just because it's more interesting, but even to notebooks, which is something that you usually need a special plugin for. On Dagshub, you can actually see a human readable diff of your notebook built into the system, not only seeing the cell code changes, but even seeing outputs. So on the right here, we have the first version of my model. You can see that the predictions on the right of it are pretty bad. Like this is what my model predicted, and this was the expected outcome. But on the left, where I have my latest model, it's already pretty close. So you can see that I actually improved. And this is actually a way that we see some of our users creating custom visualizations, because you can have a notebook that runs certain charts or plots or whatever you need, and then compare them across versions so you understand how your project has changed over time in a way that is meaningful to you. So you don't have to rely on things that we have built into the system. You can customize it to your own needs. So we went over the data part, right? And this again applies to models as well. But the other part that we provide is a data pipeline visualization. And so here you're actually seeing a DVC pipeline, and we'll get to MLflow in a moment. But you're seeing a DVC pipeline, which is basically the way data flows within your project in a visual way. So if you've never looked at this project, right, and I'm now explaining to you what you're seeing. So even though you're sort of now joining my project, I can easily explain to you that's what's going on is I'm bringing in some data from the internet. I'm starting to track it here, and then I'm running a processing step where I get processed data. It's split into a train and test set. And then I take the train set, train a model, and I take my train model and the test set, and I evaluate it. And this is exactly the way the project is structured. It's very easy for you to sort of understand what's going on and what depends on what. And so if you want to see the test set, you can actually use this to navigate and find exactly that data. So I can actually look at the data set and navigate the project via its structure, which makes it much easier to understand what's going on and sort of share it across the team members, whether it's new team members or maybe the team leader or someone else that's just wanting to understand what's going on. Same applies for metrics. So if I want to see how my model performed, I can actually see it within this pipeline. So you can see it here. And this is all version specific. So if I go back to the past, I'm actually going to see how the pipeline looked at that point. So it's also versioned, and you can see the change in your data pipeline over time.
So this is essentially the DAGs in Dagshub.
This is, yes, exactly. So this is a DAG. That's a good observation. And this is the original reason why we called the company Dagshub. We thought it's going to be like a DAG more generally, right? Like we built this feature, but we also thought like a DAG describes the general structure of a data flow within any machine learning project. So Dagshub is in the sense of this is the hub of describing how your data is going to change and be modeled and train the model on it, etc. So yeah, this is it. This is the DAG from Dagshub.
Awesome. A question around on the data, because DVC in particular leverages Cloud Object Store, but I know you also have your own version of a free tier of Cloud Object Store you make available for free users. The question I have is around, there is this move to data lake type infrastructures where the modern cloud data platforms are providing some form of an object store in the data lake and the database gets to manage that. What are your thoughts around integration to those types of platforms as opposed to just native object store? So thinking about like Snowflake and a data lake on Snowflake where you want to interact with that data for the training.
Yeah, sure. So generally, the way we think about this today is if your data is stored only in a database, then probably DVC is not the best tool for the job. And therefore, Dagshub, we'll talk in a moment about experiment management, but at least the data management capabilities of Dagshub are less relevant if you have like an SQL database and your data is stored there. Now, what you're talking about is a more complex situation where maybe I have an object store, but it also has some SQL store or SQL database that's sort of managing access to those files and things like that. I think in those cases, behind the scenes, Dagshub can also provide access to those files. But the way we think about this is like data lake is an architecture for how you're managing your data, and Dagshub is a tool to manage data within machine learning projects. So in the concrete example that, let's say you have a giant data lake, right? You're not training your model on the entire data lake. You're probably querying a subset of that data, and then that's what you're training the model and experimenting on. So the raw data in those giant, petabyte scale data lakes should stay in the data lake, and it's usually not versioned, and it doesn't make sense to version the entire thing. What you should version is the actual set of data that you're training your model on, because that's what's going to help you reproduce your results. And those subsets of your data should be tracked by something like DVC and stored on Dagshub. So that's sort of the base relationship with these tools. But of course, it really depends on the implementation detail here. And I think that in the end, the way we're thinking about this on Dagshub is that it's supposed to service the teams that are building the actual machine learning or data science projects, as opposed to the like data lake, which might service also like data engineers and analysts and things like that across the organization. So yeah.
Awesome.
Amazing. So once you have all of this set up, right? Like let's say you built your pipeline the first time, right? And you have some model, the next step is going to be experimentation. And that basically is a major part of any machine learning project. And so we wanted to support that next step on Dagshub as well. So we have an experiments tab, and that experiments tab basically supports two types of experiment tracking. The first is Git experiment tracking, which I'll show in this right now, and then I'll show some of the MLflow stuff. I do have some MLflow project experiments here that are hidden just to show how that looks. So you can see an MLflow experiment basically has an MLflow source. A Git experiment has a Git source. And the difference between them is MLflow is using the MLflow API, which most users will probably be familiar with. In the case of Git, what we wanted to do is we wanted to support a very reproducible way to track experiments. So if your Git commit includes parameter and metric file, in a generic format. So the parameters is like a YAML with a key value pair, and the metrics are CSV with a very simple human readable format. We know how to automatically parse that information and build out an experiment from that. So you can do everything that you can do with regular experiment tracking tools, including MLflow, like looking at the columns and the parameters and the metrics, changing parameters and metrics, and doing things like comparing your experiments. So in this case, I have 3 experiments that are basically the same model, but trained for different periods of time. And so I'd expect them to be better as time goes by. I can see a tabular comparison here. I can see a parallel coordinate plot, and then which is customizable to see whatever metrics you want. And then I can see a side-by-side chart view, which is usually what you need in order to understand whether or not an experiment is promising and if you should focus on it or not. But as I mentioned, we also have full support for MLflow. And that means that we also support MLflow's capabilities around deploying models and containerizing them, etc. And so every Dagshub project comes with an MLflow remote. And if you prefer to see the MLflow UI over what I just showed, you even have the MLflow UI right here. So I can open this and I can show you what's going on in my project. In this case, I have a few experiments that are mostly, like, I didn't even track parameters and metrics here. I only use MLflow in this project to productionize my model. So I'm actually mostly relying on MLflow's model registry, which I can fully use on Dagshub. So I can see that in this project, I'm using a fast AI model. So I can actually see the details. Sorry, I think I downloaded that. Yeah, here I can see the actual model and I can see the code that gets me to run that model. And then I can register it, which I already did, and deploy it on AWS on your own Docker container or anywhere you want, right? So we even support you in getting to that last stage of containerizing your model and putting it somewhere. But this is all based on MLflow and MLflow's deployment capabilities because it's great and there's no need to reinvent the wheel. Last thing I want to show, I guess I'll stop here if you have any questions about experiments, and then I want to show annotations.
This is really good. And maybe you're going to touch on FastDS. There is FastDS in the picture for the audience. Do you want to talk about what FastDS is and how that ties into the work at Dagshub?
Yeah, so let me go to the homepage so you see the nice visual effects.
It's a beautiful homepage.
So we basically, obviously we talk to a lot of data scientists and specifically a lot of people that are using the tools that we integrate with, namely Git, DVC, MLflow, Label Studio. And one of the things that we noticed that people were talking about a lot is the fact that Git and DVC are very closely connected, but they do require a lot of duplicate work to do. So in the example that you're seeing here in the GIF on the website, is basically, if you want to initialize a project, you need to do Git init and then DVC init, right? And the same goes for committing, for pushing, for pulling, for all of these actions. So with FDS, we basically combined everything in a smart way so that you can do one command, FDS init, and it does both. And this applies to a lot of other really cool, smart things that we did. For example, this, right? So when you add files, there's a lot of time a question of whether or not a file should be added to DVC or Git. And it sometimes is confusing. So what we did is we created sort of a wizard within the command line that lets you infers from the file type and size whether it should go into one or the other and suggest where you should put it. So this simplifies your experience significantly. And all of this is open source. So, and completely, usable with DVC. It's not related to Dagshub at all, but this will let you have a much better and simpler life when you're working with DVC. So I recommend it. And if you have any feedback or suggestions, we're very open to hearing them. So this is one open source tool that we have. Another thing that we launched relatively recently is something that's called a direct data access, which I'm probably not going to demo because it's a CLI tool that requires a bit of coding, but you can check it out both in our docs. I'll show the place where you can find it. So if you go to direct data access here, there's a video explaining it and how to use it. But basically what it does is, again, we were talking to a lot of our users and we noticed that a lot of them have a lot of data and they want to do certain actions like streaming their data to where they're training their model or uploading a single file to DVC, which in the command line version requires you to download all of the files, compute the hash again, and then push the new file. So if you have 1 million files and you want to add just one, that's a pretty painful process. And so what we wanted to do is we wanted to build a way to simplify those flows And that's exactly what direct data access is. So it's part of the Dagshub client. You can pip install Dagshub and you get it as part of that. And that means that every Dagshub project, you don't need to do anything. You don't need to change your code. You don't need to support some interface for your data. Becomes fully streamable. So you can download only parts of the data, stream it into your training loop, etc. And also you can upload files via a Python API. So basically you can do Dagshub upload file, and then we make sure it's calculated and put into the DVC tracking as it's supposed to be. So that's also something that might be useful to a lot of users in general. Last but not least, I'm going to go to a different project that has some annotations in it. Data is arguably the most important part of our work as data scientists, right? We even have it in our name. And so a lot of the work around data involves getting high quality data that you can train your model on. And one of the things that we notice when speaking to people is that there are many ways to annotate data, but one of the challenges is around how do I get the data from where it's collected to where it's going to be annotated? And then once it's annotated, how do I get it back to where my data scientists work so that they can train their model? And in order to make that process simpler, we integrated with Label Studio, which is a great open source tool for annotations. And what this means is that every Dagshub project has an annotations tab, and Label Studio and therefore Dagshub supports a ton of different data types. So I'll show image, but you can also do this with, you see a bunch of other data types. And the idea is you have Label Studio instances that are integrated with your project on Dagshub, and you can actually see them and actually annotate your data in real time. So I'm going to open this one, for example. So this is from The Mandalorian, and we're trying to segment the different characters within the image. Now, there are two differences from a standard Label Studio instance to the one you're seeing here. The first difference is that when you open this for the first time, it'll let you choose the folders or files within your Dagshub project that you want to annotate. And what that means is that once you've uploaded your data to Dagshub, you don't need to do anything at all in order to annotate it. You just open this instance, say, here are the files I want to annotate, and you're good to go. You don't need to move them anywhere. You don't need to send them, change their format, etc. We do everything. The second is, once you've done annotating your data, we added this commit button, which you basically can commit all of these annotations to a standard format in your project so that you can then time travel an annotation. So if you want to go and look at an older version of your annotations, you can go back to an older version, open a Label Studio instance for it, and then you're seeing everything as it was at that time. You can compare annotations, which I think I have something to show for that in one of these pull requests, or maybe this is not the one, but yeah. But you can compare annotations and see how things change over time and see sort of what's going on here. This is an example. So you can see I added an annotation within the image, and you can see what it was before and after and decide whether or not this is something that you actually want to merge into your project. Maybe annotations became better, but maybe they became worse. And so you get, again, the same experience as you would with your code and with your data, with your models, but now with annotations as well. So these are some of the core functionalities of Dagshub. There's a lot of additional things I could show, but I think this is maybe a good place to stop and see if you have any questions.
This is pretty fascinating. And so based on what I've seen here, there is GitHub, there is Git or GitHub, there is DVC, MLflow, Label Studio. For the end user coming into Dagshub, do they have to have separate profiles for each of those platforms to use Dagshub, or do you see Dagshub potentially leveraging service accounts into those different services and making it, you have one login to Dagshub and that's all you need, and you can use all of these other capabilities? What is the thought or the vision around something like that?
So actually, this is already a solved thing. So what I mean by this is, first, when you sign up to Dagshub, you can sign up with your, your Google account or your GitHub account. It just works, right? But the other thing is, all of these tools we have built-in integrations for. So if you go to any project, to any of your projects, and you look at the settings page, we have an integrations page. All of these integrations have a built-in configuration with Dagshub. And what I mean by this is that if you're connecting an S3 compatible storage or something like that externally, you actually click this. There's a wizard that helps you add in your bucket details, and it just works. And if you're using Dagshub storage, which is our provided storage for DVC, you actually don't need to do anything. Like you can open your remote, go to your DVC remote, and you're going to have the code here that you can copy and just set up authentication so it works. And the same goes for MLflow. So you can see there's a few environment variables which you can set here. We suggest the way that we recommend setting them, but you can do this in other ways. Once you set these environment variables, it just works. You don't need to do anything. And the same goes for Label Studio. So everything is hosted on Dagshub, and we know to connect with most of the storage types. So even if your storage needs to be external, the experience would be a single access to Dagshub that provides you everything that you need.
Oh, okay. That's fascinating. And I think you touched already on the pricing option here, essentially a freemium model.
Exactly. So it is freemium, where we think that you should be clear on how valuable Dagshub is before you pay, not after. And so you can basically use all of the features that I just showed for free. You can make sure that it works for you. And then if your team wants to use it, that's when it starts becoming paid. And that sort of made sense to us. We are developers and data scientists ourselves. We know how we like to pay for tools like this. And so we try to do the same unto others as we'd like done unto us. So yeah.
Okay, very powerful. And then for the storage point of view, of course, if your data is in the Cloud Object Store, what essentially means, well, that residency is on wherever you choose for that to be. But on your internal storage, if a user has requirements that needs data residency in a particular cloud or geolocation, how do you accommodate for that? Or would you just recommend, hey, put it wherever you want in the object store and then connect to it?
Yeah, so there's different levels of data privacy or data constrictions, and different cases apply, right? Like the most general case is you don't care where your data exactly is, in which case Dagshub is probably, like, putting it on Dagshub storage is the easiest way to configure it. And so that's sort of one solution that just works. The more complicated case is, as you say, let's say your data is either somewhat private, so you can connect it, but you want it stored on your own buckets, or you want it at a specific geolocation, in which case, yes, we support connecting external storage. You should put it on the bucket that you want and then connect that to Dagshub. The experience, by the way, from the perspective of the user is the same. Like, you don't know that behind the scenes there's an integration, except for that you see it here in some projects, like you'll see S3, so you know that someone connected their S3 bucket. But aside from that, there's no difference. In some cases, we do work with companies that have very sensitive data, like medical data or government data and things like that, in which case we also do support on-premise installation as part of the enterprise tier. That is, if that's relevant to someone, let us know, and we'll be happy to assist.
Yeah, pretty fascinating. So let's talk about the community and the support, because you echoed this in the beginning, where folks are not just building products. They're trying to build communities around this. And that's what GitHub did really well. Sometimes I go on GitHub and I'm looking at a project to see how many stars it has, how many people are following that project, and you want to jump in there and be a part of it. It sounds like you're trying to take that same community-driven approach and collaborative experience to the data science world. How are you seeing the reception and adoption of that from the community?
Yeah, so I think a lot of people are very excited about building machine learning models and sharing them with the world. And I think that that's something that we're already seeing. Like, we're seeing university professors ask their students to submit their projects on Dagshub. We're seeing researchers build out their project on Dagshub before they submit the research for review in a journal, so that it's fundamentally reproducible and the data is as accessible as the code, which, as you probably know, is a meaningful problem when people just, put out their code. You have no idea how they got to it. You have no way to actually reproduce the results. That's a huge challenge. On the sort of next level of that, I'd say that we are already seeing a bunch of collaborative projects where people are working together on the data science aspects, but we're still thinking about what could be the next step. Like, what could be a hugely collaborative project? We are seeing projects with, 50 collaborators working on towards a similar goal, but I think that we're still looking for that, React, where you have thousands of contributors and things like that. The world of machine learning is a bit more complex with that respect, right? Because you need to be able to manage larger amounts of data and a lot of compute resources in order to make some of the more complex models accessible. But I think it's still sort of the general direction in which we're heading is that more models become accessible, even though the greatest models are still something that only happens in large organizations. We're already seeing a lot of the work being done on people taking those models, modifying them, and then making them accessible.
Awesome. And I just have to call out there, you have a Discord channel as well for folks who want to
Yes.
participate. We're going to leave a
Yeah.
link to that in
So
the description. Yep.
yeah, and if you're on the website, this Discord button goes to that community from every page, so you can easily find it.
Yep, awesome. And Dean, as the founder, the CEO, the leader of this platform and this tool, you definitely have visions that have not necessarily materialized. Can you share what the outlook for this space is? What is the holy grail, or what it is keeps you up at night as you're working and building out Dagshub and the community around that?
Sure. Yeah. I'll shout out my co-founder and partner, Guy, who's also the CTO. And a lot of the thoughts that I have on this topic also come from the way he analyzes things. So if I'm looking at the machine learning world in general, right, and I'll try to fit in Dagshub into this vision, I think that today, right, like, and when I say today, I actually mean like in recent times, I think it's becoming increasingly clear that like machine learning is going to change the world that we live in, as opposed to some technologies that, you know, we like talking about no less than machine learning, but haven't really gotten to the point where they're applicative. So it's more theoretical and high level. Machine learning is already being incorporated into real products that millions of people use. I'm not only talking about, you know, the larger corporations like Google or Facebook. I'm also talking about smaller startups that are using AI for transcription, for text generation, for image generation, but also for, you know, legal document analysis. It doesn't have to be one of the flashy big things that everyone is talking about on LinkedIn. And I think that that's not a trend that's going to stop in the near time, right? I think that we're going to continue seeing machine learning eat at software. Like, if you're familiar with the saying, software is eating the world. So AI is eating software. I honestly believe that as time goes by, this is going to be a more important part of the way we do software, the capabilities that we provide users, etc. And so it's very clear to me that more and more people are going to be working on these problems as the future comes. But when we're looking at the people that are already working on this, it's not very clear that there's a set of standards and tools that are the de facto way to work on machine learning projects. And that's sort of the thing that we noticed that got us started on Dagshub. And I think it's still, for good or for bad, still pretty true today. That you go to different teams, and first the workflows are wildly varying, not because they have to be, but because a lot of these things weren't set a few years ago, and they're becoming sort of well-defined right now. And so these standards need to exist, and they're going to exist in the not too distant future. And someone is going to need to provide those standards. And I firmly believe that the person that defines those, or the company that defines those standards, has to be very community oriented. And people need to be able to run processes of community collaboration on it. And that's why we're doing what we're doing at Dagshub. Like, the idea is that collaboration is, you know, it's as large as the community building the next cool model in the medium level within a company where you have tens or hundreds of data scientists that need to work together in order to get a competitive edge or build a product. And then it goes down to the smallest level of, you need to collaborate with your future self and know what you did 3 months ago. And there's the programmer joke about looking at horrible code and then checking who wrote it and realizing it was you a few months ago. So you need to be able to understand why you did the things that you did and be able to reproduce the results that you had in the past. And so that's what Dagshub is trying to solve for. That's what we're this platform for, and the things that we care about.
Wow, that's pretty fascinating and refreshing. And I like the collaborate with your future self. I think that's something we all can take into practice for ourselves. Now, before we drop off, just because it's out in the news recently and every founder seems to have an opinion on this on LinkedIn, I want to get your thoughts. What are your thoughts on ChatGPT?
Yeah, fair enough. So, Lee, today is sort of an average day, right? And I found myself talking about ChatGPT. This is the third conversation. So it's definitely the hottest topic in ML news, and arguably also not in ML news, just like in general news that's going on right now. I think that first, I guess, if someone is living in a cave and hasn't heard what it is, there is this a large language model GPT-3 that everyone really was talking about as it came out, and it was oriented towards interface of prompts. So you would basically tell the model what to do, and then it would try to do that. But the OpenAI, which is the company behind that, basically released a version of this model where the interface is no longer prompts, but actually a chat. So you talk to it as if you talk to someone else, and it tries to respond. And you can ask it to do things on the way. And people realize that that's a much better way to interact with language models, or at least it seems like a better way to do that. So first, I'll echo something. I'm not sure who is the first person that said this, but there have been a few voices on LinkedIn that were talking about one of the biggest problems in machine learning not being the models or the data, but the actual user experience. And that a lot of teams are working on building really powerful models without a clear way of how it makes sense to actually use them and get value out of them. And so I think ChatGPT is the first of many, I believe, interfaces that suddenly become much more intuitive for people to use and much more powerful because of that. So I'm guessing that the model behind ChatGPT is not orders of magnitude better than GPT-3, but the main difference is how it is made accessible. And so I think that's a very, very interesting idea. And if you're a founder or data scientist working on machine learning tools, thinking about this problem for the models that you're building is really, really important and can actually make a huge difference in the end result of your work. So that's one take, which I guess is not that controversial. If you ask me where I think this is going, I would say, again, we're going to see more of these. We're going to see these in other domains. My bet would be Chat GPT, but in audio sounds like something that would make sense. And if it works well, because Siri sometimes misses what I want her to do. So if it works well in the sense of voice recognition, then that could be a very powerful tool, maybe closest to what everyone always talked about, an AI personal assistant that we've seen so far. But I also think that there's going to be a lot of interesting work done on making that accessible to specific individuals, professionals, and things like that. But yeah, it's early days, so we'll have to wait and see.
Yeah, you couldn't have said this any better. Well, I think that wraps it up. Any last words for the audience where they can find you? We're going to leave links to all of this in the description below. This has been very illuminating. Dean, thank you so much for coming on board. Any last words or things or call outs you want to do?
Yeah, sure. So you can follow me on Twitter or LinkedIn. I'm happy. I share more content like this and sometimes my opinions about these things. You can go to our Discord. I really recommend it. We're building out a community that is not just around Dagshub, but also just people that are enthusiastic about machine learning and machine learning in the open. So if that's something that you're excited about, we'd love to see you there and hear your thoughts. And then if you're working on machine learning projects and you feel like a central source of truth, a way to reproduce your work, a way to share it is something that you could get value out of, then maybe you should check out Dagshub. And that's it.
That's awesome. Dean, well, thank you so much for coming to the show. And thanks everyone for watching. We'll see you in our next episode.
Thank you for having me.